Hi guys, my name is Asad Mirza, and I'm a PhD student here in the biomedical engineering department, and I have been tasked with making these videos to accompany the BAB 1054L Introduction to Biomedical Engineering and Computing course, and I hope you'll find them useful. And let's see, without further ado, let's get started. So, first off, at the time of making this video, the professor for this course should be Dr. Nicholas Zukias, so if you ever need any help, go to him. There should also be a TA for this course. You can also go to them. I don't know who that would be in particular. They change semester to semester. But if you ever need help, I would suggest you go talk to them. You could also Google MATLAB tutorials, and there's also a book accompanying this course as well as PowerPoint slides. So first off, what is MATLAB? So MATLAB is a programming language, but it's also a programming environment. Now, we mainly use it to solve numerical methods in biomedical problems, but it's a programming language first and foremost. So if you have any experience with, let's say, Java or C or Python, it's similar in those aspects, but it's much more readable and easy to understand, hence why it's widely used in academia and in industry, where we care more about the results, less about the base coding that it's built upon. Now, if you remember looking at the prerequisites for this course, you don't actually need any programming knowledge per se, which is completely true, because we're going to start right from scratch and build our way up. However, if you do have some programming knowledge, you're going to see that this is very similar to things you'll learn in Java, C, Python, and so on and so forth. So after you have finished this course, what you'll find is that you'll be able to use MATLAB and be able to transition to other programming languages because they're going to be very similar to each other. So first off, MATLAB, what is it? Well, MATLAB stands for Matrix Laboratory, and if you recall back to, I believe it was linear algebra, where you should have been introduced to matrices. A matrix is literally just an array of numbers that you can use to store data of some kind. And what MATLAB is really good for is processing this data. And because an array of numbers can be a single one-dimensional vector, a two-dimensional array, which would be a common matrix, three-dimensional, four-dimensional, higher dimensional, these are all just numbers that are being stored in some sort of format, and that can be applicable to any field imaginable. So MATLAB can be used to process all of that data seamlessly, easily with its accompanying modules and toolboxes and everything, and you can use that to write programs and scripts to solve all kinds of problems that you'll see both in this course, the next course after this, the modeling simulation, and courses after that, transport, senior, and beyond. So first off, how do we actually get access to MATLAB? Well, you can go to this link right here in this in the PowerPoint slides, which is very long and complicated, but if you just click it, it should bring you to this page right here. However, if for some reason that link isn't working, you could always just type in FIU MathWorks, and it should be the very first thing that everybody sees. So for International University MATLAB Access for Everyone, go ahead and click that. Now you're going to have to click sign in to get started. And it's going to ask you for your FIU username and your password. Your FIU username is the same one that should work for your Gmail. So it should be the first letter of your first name, then it should be the first couple letters of your last name, and then some numeric thing at the end. I'm not entirely sure what that means, but it should be this format. And your password by default should be your date of birth, I believe. Now, if you forget what your username is, you can go to these links here for your username and password. And these are the exact same credentials that you would usually use for your MyFIU. So, assuming you have this, go ahead and log in. So now that you've logged in, you can see here that it's automatically associated your MyFIU account with MathWorks. But now you also need to make what's called a MathWorks account, which is specific for MATLAB. So now go ahead and click sign in. And over here is where you would click create an account if you didn't already have an account, which you probably know. But when you click create account, just use your FIU email. This is crucial. It has to be your FIU email because that's the email your licenses are registered to. Answer some quick survey questions and then click next and create your account. You probably will also have to verify, so make sure you check your email for that. But once that's done, you can go ahead and click sign in. So now you'll be asked to download which release you want. Now, at the time of making this video, the latest release is R2019A. So go ahead and download this and run the file, and it should create a temporary folder where it extracts the installation file, And when you open it, this is what you should see. MapWorks installer, and it'll ask you for two different things. So one, you can log in with your MapWorks account or have file installation key. So log in with your MapWorks account, click next, click yes. Now you're gonna have to type in the exact same MapWorks email address and password as you did before. So let's see if I can get this in one shot. Yay, awesome. So now you can select which license you want to use. Now you should have an option for two different things. One should be campus, one should be individual. You might not, depending on how the university deals with its bulk licenses in the future. But currently there are two licenses, campus and individual. As far as I remember, individual is limited to 4 computers, so you can have it on your personal computer and 3 others. Campus is indefinite, but it's restricted to computers that are under FIU's domain, I believe. So because I'm sitting here in my cubicle in the BME department, I'll go ahead and click campus. But if you were doing this on your laptop, just go ahead and click individual, and you would use up one of your 4 allotted licenses. So now click where you want to install. So now you can see here that you have the very list of products that is going to be installed. All the recommended ones are pre-selected. So the first one is MATLAB 9.6, which is the core MATLAB that has the bulk of the functionality, and everything else associated with these boxes are what are called modules. So you have modules associated with, for example, bioinformatics, so genes, enzyme kinetics, stuff like that. Curve fitting toolbox, so polynomial fits, spline fitting, stuff like that. Deep learning, if you're interested in the area neural networks, that would be found inside of this toolbox. We also have various things, for example, image acquisition, if you want to start recording video. If you do plan on using any of these extra modules, MATLAB will tell you what you need. So for now, just click next. And now you can go ahead and activate MATLAB, click next. And it should automatically be activated because we logged in using our MapWorks credentials. So now let's go ahead and start up MATLAB. So for me, I should just look up MATLAB and you see 2019A. Oh, look, the activations have appeared. So let's first take care of this. Click next. It should validate. It should be based off your email address and your license number. So go ahead and click confirm. It should activate. Done. Now let's actually open up MATLAB. So MATLAB R2019A is the one I have. And if you are on Linux or Mac, it should be slightly different, but MATLAB should have installed somewhere on your computer. So go ahead and click it, and then it should open up. Now this should take a varying amount of time depending on what your system is, how much RAM it has, CPU, and such. But generally, the first time should only take less than a minute, and after that, it usually speeds up. So I'll see you guys when MATLAB's opened up. Guys, now I'm back, and MATLAB's loaded up. So before I go into any details about what all these little tabs and buttons and everything means, first let's fix some of the font and the colors. So usually when I'm working with MATLAB, I find the default color scheme and font sizes to be just a bit too small and a bit too drab for me. So what I'm going to suggest you guys do, go to preferences first, then go down to first fonts, and to make things easier to read, I'm going to set the font size for this to be 18, let's say, and then for desktop text font, also make that 18. Click apply, and that should increase the font size everywhere. So this should really help if you are on a Retina screen, such as for a Mac. Now the next thing I want to do is, because I'm usually coding in the middle of the night and I find the white screen to just be too much for my eyes, I usually change the colors to having a black background. So you can change the color scheme using here and over here. So I already did that, so I'm just going to go ahead and unclick use system colors, click apply, and now you have this black background, white text, black background, green text, much easier on the eyes to see. So now that we're here, let's go ahead and see what all these little tabs mean. So if your window does not look like this, you can go down to layout, and by default, it should look like this. So it should show you the current folder, workspace, panel titles, and tool strip. And I also suggest you select command history to docked. So that should bring up this thing right here. Now yours shouldn't have this empty. Mine has some examples here because I was still writing in it before this video. But now let me go ahead and explain what all these little sections mean. So first off, what is this command window here? Command window is essentially a glorified calculator. You can use it to test out your code and, like I said, as a calculator. So if I were to say, let's say 5 plus 4, it says ans is equal to 9. So it just acts like a calculator. If I want to do, for example, what is the sine of 45 degrees? 0.07071 square root of 2 over 2. So this is just a glorified calculator. You can test your code in it. And if you noticed, when I was writing all these things out, over here in what's called the workspace, something got created called ANS, and then it got the value of the thing I just wrote. So this is your workspace, and the workspace stores all your variables. So if you were to, for example, type in A is equal to 5, and then B is equal to 6, you can see A and B get stored here, and they have a value corresponding to what you said. And if you notice here, you can also see what the size is, how much memory it's storing. And I also like to put this class thing here so I know what type of variable type it is. Not too important for you guys just yet, but over here is where you just have all your variables. So you can also do combinations. So for example, if I were to now do C is equal to A plus B, now you have a new variable being made. So that's how this works. Now over here, if you notice, while I was typing in all my commands in the command window, the command history stores a record of all your different commands. You can always bring them back up if you forget them. Another way you can bring back your old commands is if you just type the up arrow key, and it brings up the next command over, and over. And this way you can cycle through old commands if you just want to test stuff that you have previously written. Now, what is this folder right here? This folder right here is called the current folder. The current folder stores all the files that are related to whatever you're working on at any specific moment in time. And by default, I believe MATLAB drops you off into one of its main folder directories here. So you might see some weird files here. I always suggest you change your working folder to whatever specific folder you want to store your code in for a specific project. So the way you do that is you click this little button right here that says browse for folder, click that, and then just navigate to some folder location where you can just test out some code. In this case, I'm going all the way to a specific folder that I'm calling test code, and I'm going to be working inside this folder for this module. Now this last part right here, details, if you have certain files in here, images, audio files, files that store data, this window down here, the details, which currently my face is blocking as I notice, it will show you details about that file. So now let's go into some main commands that you might find useful. So you can already see, and I've already shown you that you can do some basic algebra using this command window. So if I were to say, for example, x equals 3, and then y equals x plus 4, I can see this 7 show up. And you can also do multiplication, so you can do like 2 times y plus 2 times x, and now it's 20. And as these variables start piling up, let's go ahead and see. So if you don't want something to be outputted straight to the command window, you can use the semicolon. So let's say I want to write x equals 3 again, but I don't want to see the command output for this. If I put a semicolon here, which is right next to the letter L on your keyboard, it will give that command and it'll evaluate it in your workspace, but it won't actually output anything for it. Now the next thing I want to tell you guys for is the help. So what is help? So in MATLAB there are thousands and thousands and thousands of functions, but if you don't know how to use some of them, you can ask MATLAB directly for help. So let's say, for example, you wanted to figure out how to save some data. So let's say you were working on some complicated code and you wanted to save all this data somewhere. So MATLAB has a function called save. And you type help save, you'll get all this text showing up. And if you scroll all the way to the start, you'll see, oh, save is a function that saves workspace variables to a file. Sounds like something we need. And then it gives you examples of how you do it. So you type in save and then whatever file name you want, and it gives you examples of how you should do them. And then there are various extra things you can add onto it. But for basics, that's all you need to do. You just need to type save and the name of the file you want to save it to. That will save all the variables to your current working folder for that function. So let's go ahead and see if we can use it. Type in save, and then let's just do test. And if you notice, MATLAB already gives you suggestions on what the various inputs can be. So let's just call it test.mat. And then you can see automatically you have this map file created. And this map file is a MATLAB file that holds all the variables from your workspace. So now, if I wanted to, and if you looked into this lower left-hand corner where my face is blocking, you should see all the variables associated with this file in here. Now, there are other ways you could have saved the data. So if you didn't want to use this command, you could have always highlighted all of these, either clicking and then Control or just doing Control A, right click, and you could have clicked Save As, and then you could have done the exact same thing here. You could have saved it as a map file, and it would have done the exact same thing. So beyond save, there are other functions that you should know, just common ones. So as you can see here, we've been typing in this command window for a while, but let's say you wanted to start from scratch essentially. If you want to clear the command window, the function you want to type in is CLC, which is basically just clears the command window, and that clears all of that. Now, if you want to get rid of all the variables in your workspace, type in clear, and that will clear all the variables in your workspace. It's if you type, and if you want to, for example, load all the variables from a map file, type in load, and then the name of the map file. So load test.mat, and that will load this exact file into here. There are other various kinds of functions that are so-called basic, but for example, if you want to know about all the variables in your workspace and you didn't want to look at it, you can type in ooze, and they'll give you a list of all the variables that currently exist in your workspace, as well as the class, how much memory it's taking up, general interesting information. If you want to figure out, for example, what directory is my current working folder in, you can type in pwd, and that'll tell you the directory that everything is being saved into right now. And I believe the PowerPoint slides that accompany this module have a list of these types of commands that you can go through. So I believe that is everything in terms of just the general setup and most popular used functions. But now I'm going to talk to you guys about how to write code in the next video. So see you guys then. There are generally three ways you want to code things in MATLAB, and they are through using the command window. There you can also write what's called a script or an M file. And the third way is writing what's called a function. The function we're going to get to in the next module, and the rest of this video I'll just explain how to do it using the command window and what are called scripts or M files. Now, if you type something into the command window, as you've seen before, it just goes line by line by line and it evaluates. But if you want to save something for later, and you want to go back to your code and edit it and see it, how it works, that's where you'll use the script. So first, let's go ahead and write some code in the command window, and then we'll switch over to the script so you can see the differences. So let's see, the first things first, let's clear out the command window by doing CLC, get rid of all our variables, put them clear. And now we're going to need an actual problem to work on. So if you go back to your module, not the module, the PDF, there is an example where it asks if an individual borrows $1,000 at 5% per year for 1.5 years, how much interest must be paid on the loan? Now, this is a very simple financial formula, which just amounts to multiplying the three numbers together. So let's go ahead and create some variables for all of these. So the individual borrows $1,000. So let's say that what's a good variable? I believe that $1,000 will be the principal amount. So P is equal to 1,000. And I don't want to see the output, I just want MATLAB to evaluate it, so I'll put a semicolon there, and then you get the P equals 1,000 over here. And it's at 5% per year, so I'm going to go ahead and convert that to a decimal place. So let's call that the rate of interest, so that's R is equal to 0.05. And then the amount of time that gets allotted is 1.5 years. So now you have your three little variables, the principal amount, the rate of interest, and the time. So the interest rate should just be taking all of these and multiplying them. So P, and you can use the time symbol, which is, it looks like an asterisk. And it's right above the number 8 key, so that's P times R times T. And then the output of this is 75. So $75 on a principal amount of 1,000 with interest rate of 5% per year after 1.5 years. Simple enough. So let's go ahead and do the second problem, which is, let me bring it back here. If an organization invests $13,000 at 4% per year for 3 years, how much will the investment be worth at the end of 3 years? So this is just taking problem one and doing an extra step after. So let's go ahead and change some things around. So now our principal amount is no longer the 1,000, it's the 13,000. 13,000 now. And let's just do CLC, so there you go. So now the rate of interest is 4%, so it's 0.04, and the amount of time now is 3 years. And because we want to know how much will the investment be worth after 3 years, we don't want just the interest, we want how much it will be worth after 3 years. So we're going to say the interest amount is equal to whatever you're starting off with, in our case 13,000, plus whatever the interest is that you accrued. So P times R times T, and this should give you the original amount plus the extra because of interest. And you get this value. So that's a very simple way to write your code. You can do it all in the command window. But I'm sure, as you've noticed, typing each line out individually and then keeping track of it is a bit tedious. You have this command history here, but it's not ideal. So usually I use the command window as just a calculator to test things out, test ideas in, but nothing to really solidify my code in. If I want to actually write code to save it for later, that's where a script is for. And for the vast majority of this course, you're going to be writing many different scripts, and as you'll see later, functions. So let's go ahead and clear all this out. And now let's actually write a script. So how do you write a script? So there are many different ways you can start. So you can click this button right here that says create a new script. You can also type in Control-N. So if I press this, it makes a new script for you. You can also right click here into your current working folder, go to New, and click New Script right here. And that will make a blank script file that also is called Untitled. And if you were to open this up, you'll see the exact same window show up here in your what's called the editor tab. And then there's a third way that you can write a script, and that's if you just type in the command window edit and then whatever name you want to give your script. Now, by pure convention, usually the main script that you're working on for your code is called main. So let's just call this main. Main works. So you type in edit main, and it makes a M file called main, and this is where we'll be writing our code. So let's go ahead and do the exact same thing we did before. We're writing all of these out. So if you wanted to, you could just click all of these and then paste them here from the command history. And if you see this little asterisk symbol right here, that means your code hasn't been saved just yet. So press Control-S to save your code, or you can press the save button right here, and now your code is saved. So even if I were to close it, as long as I open this up, you see your code again. Now, this is great because it has your code here, it has everything fully written, but how do you actually execute this code? Well, if you want to execute your code in the command window, you just press enter. But if you want to execute your code inside of an M file, you have to run the code. And if you notice, the moment I entered into this enter, this new tab showed up here, along with 3 extra tabs, publish and view. We'll get to those later. This enter tab is what you'll be using to edit your code and add comments, indents, whatever. But the one we're interested in right now is this run command right here. And this will run your code. You can also press F5. So if I click run, it runs your code as if you're typing all these commands out in the command window. And you see we get the exact same outputs that we got before, and it makes all the variables in your workspace as expected. But this isn't really the best way to code because sure, it gives out all the outputs that we're expecting, but it doesn't actually tell us much about our code. And the way I usually like to write code is I like to write code assuming I'm going to be going back down to this code years down the line, and I might not remember what is going on anymore when I had originally written this. So I always like to add what are called comments to my code. Now, how do you add comments to your code? So if you type a percentage symbol, that tells MATLAB to write a comment. So I can type anything I want here, and if I click run, you'll still see the original stuff, but you won't see this comment being displayed. A comment is just for the reader, not for your code. MATLAB will see this comment and just skip right over it. But you can use this to help you better organize your code, explain things about your variables. So you can say this script is for calculating principal interest. And then you can say any relevant formulas. So I is equal to P times R times T. Then you can say I can also be, well, the accrued interest can also be P plus P times R times T. So just references for you. And then you can also give labels to everything. So you can say, oh, what is this I? Well, this I is the simple interest. What is this T? This T is the time in years. What is this R? This R is the rate of interest. And this is the principal amount. Simple enough. And you can do that for all these lines. And another thing I want to show you guys is if you don't want to keep writing this percentage symbol over and over and over and over again, you just want to have like a multi-line code, multi-line comment, you can do a percentage symbol, then an open curly brace, enter, percentage symbol, close curly brace. And now anything you type in here will be a one giant block comment. So you can write, so you can bring all of this in here, Control X to cut that, Control V to paste. And now you can just write a very long, detailed comment that explains more details about your code without having to write percentage symbol over and over and over again. That gets tedious. So now that this is done, you now know how the very basics of how to write your codes. So let's go ahead and do a little bit more of a complicated scenario. So the example here is create an M file. So solve the ideal gas law for N and plug in the values given below in MATLAB command window. So we have like a volume, a temperature, pressure, looks like we have a molecular weight, we got R value, and then the number of moles. And it looks like we have to convert this moles to mass by multiplying by the molar mass. And what the instructions say is to change the volume from 12,000, 13,000, 14,000, or 1,200, 1,300, 1,400, and then assign it to variables M1, M2, M3. So we can do that using command window. You just set up your variables as we did before. You have a little formula you can write, and then you can just change this V accordingly to do it. But you can also do that in a script as we're about to do right now. So I suggest you stop this video right here, pause it, and then work on this, and then come back and see how your code looks to mine. So let's go ahead and get started on this. So first things first, I'm not going to work on this main script right here. I'm just going to exit that out, do a clear, CLC. And let's go ahead and make a brand new command, make a brand new script just for solving this ideal gas law problem. So let's call it edit ideal gas law problem. A bit wordy, but detailed enough. Now, as a sort of habit of mine, I always like to type in 3 commands whenever I start writing a MATLAB script. Those are clear, CLC, and then close all. You've seen clear before, that clears all your variables in your workspace. CLC clears out your command window. Close all figures and windows that MATLAB opens up. We'll get to what those are specifically later, but I always like to start off my code by writing these 3 things because it sort of sets you at a level playing field and make sure that the only code and the variables that you're going to be dealing with are whichever ones are generated by this code specifically. So let's just make sure this is working. Press run, and it works. Everything's been cleared. So first things first, I would suggest that we write a little comment that says, this code will solve for N in the ideal gas law. Now, usually when you're writing your code, you'll have very lengthy code that has, in your mind at least, sections to it. So just like this problem has a section where they gave us all these variable constants and then actually having the formula they want us to use, it's always good to write your codes in terms of these sections. So you can actually section your code off in terms of what you want to do. And the way you do that is you do a double percentage symbol. So percent makes what's called a break. And this break lets you section off your code. So you can say this is all parameters. And now we can type in, for example, the volume, which was stated as 1,000. And temperature was 300. The pressure was 100. Molecular weight was 29. And then R is 8.314. And that should do it. And remember, like I said before, you can always add comments afterwards. So what is this? Well, this is the volume in meters cubed. What is this? This is the temperature in Kelvin. What is this? Pressure, kilopascals. This is the molecular weight in kilograms per mole, I believe. And this last one is a constant, so m to the third divided by moles divided by Kelvin. So now, if you remember the ideal gas law, PV equals nRT. So PV equals nRT. If we want to solve for n, we just divide both sides by RT. So solving for n, we say n is equal to P times V, And then if you want to do division, you do the / on your keyboard, which would be right next to the right shift, and below the semicolon key. And then you do R times T. Now, I want you to notice something very distinct here. MATLAB takes everything very literally. So when you type in P times V and then do divide R and then times T, MATLAB will do that code sequentially in order. So if I were to go based directly off of this, you're not going to get the answer that you should be expecting. So if I were to run my code right now, if you see here, you get the moles as 3.6084 10 to the 6, which does not match the results from the PowerPoint slides. That's because what MATLAB did was it did the pressure times the volume, then it divided by the rate by the R value, and then it multiplied by T. But what we want to tell MATLAB to do is first multiply these two, and then divide by both of these. So the way you can get around that is you tell MATLAB using a parentheses. So anything in parentheses is done first. So if you put parentheses between both of these, MATLAB will multiply both of these first. And then if you put parentheses between both of these, MATLAB will divide by both of these, the combination of the multiplication of both of these first. So now if you run all the code, we get the same result as the PowerPoint slides. It's a rookie mistake, but many students always have issues in their codes because they don't use the proper parentheses. So make sure you keep track of them. Always make sure you keep track of them. And now, converting our moles to mass. So if we have number of moles, and we want to convert to mass now, well, that's just saying M, so mass, is equal to the number of moles we have times our molecular weight. So mass in kilograms. And if I run the code now, you can see it says the mass is 1.1627. E is MATLAB designation for 10 to the. So this is saying 1.1627 10 to the third power, which is correct compared to what the official answer is. And now we want to vary the volume by these values and then put them into M1, M2, M3 and see the differences. So let's go ahead and do that. So how could we change this single variable and then have that tell us what the values are in corresponding steps? The first way we could do it is just directly change this value. So right now it's 1,000 and we get this value, but now we can change this to 1,200, run it again, and we get this value, and we can change it to 1,300, and as we're changing the volume, the mass increases as expected. But that's a bit tedious, so what if you want to see all of them at once? Well, you could be a bit redundant in your code, and you could say, okay, for volume 1,200, and you can just copy this line, 200. Everything else stays the same, except the number of moles changes, and then this M changes, so I just copy and paste, and the instructions say have it as M1, M2, and M3. Let's go ahead and write this as M1. And now if I write my code out and run it, you'll see because I have suppressed all of my outputs with the semicolon, you don't see anything in the command window. But if you look over here, you see now we have a variable called M1 that states the mass, assuming a volume of 1,200 cubic meters. So now you can just copy this code, paste it again, and now this can be for 1,300, and then make this M2 instead. And then you can paste it again and do it for the final time, 1,400 for the 1,400, and then make this M3. And now if you run all of these, you can see here in command and your workspace M1, M2, M3, and you calculate for all of these volumes. But this code is also not exactly ideal because you're rewriting your code over and over and over again, and it's not the best practice. So I'm going to show you guys a different way to do this. So first off, here's a quick trick. So if you highlight sections of your code that you're no longer interested in seeing, and then you press Control R, that will comment all the code out, so you no longer have to deal with it. And if you want to undo a bunch of code, highlight and press Control T. This is the same thing as pressing this comment button up here, and undoing that is the same thing as pressing this. So what I want to show you guys is a neat little trick where if I'm only interested in seeing changes to a single variable, and I'm not too interested in just showing all the results, what you can do is, so right now, if I run this code, you get the original value for 1,000, And I'm going to get rid of these breaks momentarily just to show this neat little feature. So if you highlight any variable of interest that you want to change and you right click, it'll say increment value and run section. So now I can change this single number and it will run the section of the code. So in this case, because, oh, all right. So in this case, if I edit this single value here, and let's say I increase it by 100, let's say. Now you'll see the code has run, and you get a value here of m is equal to this value, which is the same thing we got before, but now we just click a button and it does for us. Now we click this plus symbol again, this number will go to 1200 and run this little section again, as you can see. So this is also a nice little way of just dealing with code that you just want to quickly test out, and in addition to you typing it out directly in the command window. So let's go ahead and undo all these changes. If you do Control Z. Last thing I want to tell you guys before I end off this video is a couple of these extra buttons right here. So we've only been typing in run for now, which does just as you expected, just clears, it runs all your code sequentially. But you can also, if you notice, have these buttons here that say run in advance, run section, advance, and run in time. If you click run in advance, it runs each little section of your code individually based upon where the breaks are located. So I just clicked run in advance and it ran this line of code. So it ran clear CLC close all. So it cleared my workspace, my command window, and any figure that I had open. And if I click run in advance again, it'll only run this little block of code. So it only made the variables in my workspace. If I click run again, it only found n. And if I click run again, it only found the mess because that was only part of the code that was located here. The next one is this run section. So if I click run in advance here, it clears everything. Run section will only run a specific section of code that you specified. So if I only want to run this little section right here, I can click here, the section that it's located in, and click run section, and it will run just that section. If I click up here and then click run section, it will only run this little section. Advance will let you advance through your code section by section. So it just goes one by one through it. And this run in time is really for more advanced MATLAB code. What it does, it lets you time your code and see where the slowdowns are happening. That falls way outside the scope of this course specifically, but we'll touch upon it a bit more in BME 2740, and you guys take that. So with that, you guys have learned the very basics of MATLAB and how to get started write your own code, and I'll see you guys in the next video. Thank you.